Now that we learned what a file is and how to create a path using the Pathlib library, let's talk about how to actually open and close a file. In this lesson, we're going to learn how to open a file, the importance of closing a file properly, two different approaches to making sure that a file gets closed and is always closed after done using it, and then finally some different options when opening the file. So in order for us to open a file in Python, what we're going to use is the open built-in function. And that open function is actually going to return to us a file handler. So when we do the open function, it actually doesn't return the file itself. It returns something that handles the file. And the file handler has four main purposes. It's used to open, and it's used to read, it's used to write, and then finally it's used to close a file. Now, when I say a close a file, what that means is it's no longer being interacted with this file handler. Opening means that we are now actually writing or reading things from that file itself. So things are being loaded into memory, into the primary memory for the CPU to be worked with, and vice versa. That primary memory is actually going to be loaded onto the physical file itself. It's a secondary memory. Now, close means that all of those types of interactive operations gets stopped. That those abilities are closed, just like a store being closed. That you can't go in and you can't buy stuff or interact with the store anymore. Once it's closed, it's closed. There's no going back. You can't do anything more with that anymore. So let's look at how we do this in Python. We're going to import pathlib, create our path that's in here, and then our file handler, we're going to set that equal to open and then the path that we pass in there. And then finally, I'm printing out here the file handler to show to you this actually isn't printing out the file itself. It's printing out the file handler. You can see that the name is the path that we passed into it. Its mode is R, which means it's read only, and we'll talk about the different options here soon. And then its encoding is UTF-8 or Unicode, and we'll talk a little bit about what encoding means and kind of the different options later on. But you'll remember that we talked about that there's usually either ASCII or UTF-8 or Unicode, and UTF-8 is a Unicode variant that's in there. Now, before we even get too far into opening, I want to really emphasize to you, absolutely make sure that you close your Python, close your files that you have opened in Python as soon as you're done working with them. Make sure they're properly closed. Python does automatically close all files upon its termination whenever it exits, but that doesn't mean that things couldn't get kind of hung up or have some issues that are in there. And if you have a process that's running for a really long time and you don't close out your files, that can eat up a lot of the resources. It can cause some issues and just makes for very kind of not very clean coding that's in there. So please make sure you absolutely close your files whenever you are done working with that file. And you shouldn't be a situation where you think you might open it up later on and work with it. If you're going to work with it later on and you think you might do that, just close it and then open it when you do need to use it. It's not a big deal to create a file handler. It's really easy, and you'll see that as you can see that already that's in there. So one of the issues that you might run into when opening a file is if the file doesn't exist. And actually, if you pass in a path to some file that doesn't exist, you're going to get a file not found error. And you can see that as being raised right here, the file not found here, and it's with the open path here. And it'll even give you the details of, hey, this is the location I tried to open, and definitely is nothing in there. I didn't create a some junk file.junkx. It's not good. And so this is definitely not the right thing. But remember, back in pathlib, we check to see if something exists. And we can do that here and put that in our if statement and then account for how to handle that type of situation. So in this case, I try to open up a file, and if it doesn't exist, then I just print out and say, hey, path doesn't exist. Right? If you're working in like a while loop where you want the user to actually give you a proper path, you can just keep prompting them until they get a proper path that's in there. Whatever you need to do, you can do this checking, and then you don't have to have that raise that error that's in that situation. Now, let's get back to how to properly close your file. So there's two main ways that you do that. You can either invoke the .close method of the file handler, or you can use the with statement. Now, I highly recommend you use the with statement. It is definitely preferred, but there may be situations where you just can't do that. But you need to make sure that in any case, you always close your file properly. So let's talk about the first one where you use the close method first, how we do that, and then I'll show you the with statement and why I think that's the better of the two that's here. So if you're going to use the close statement, make sure you wrap everything up in a try finally. So when we talked about exceptions in the previous module, we talked about a try except block. Now, what we're going to do here is actually a try finally. So finally is another statement that you can add to it. You can do a try and then accept, and then finally, or you can just do a try and finally. And what finally does is that no matter what's happening, the code in the finally block gets executed. So in this case, I have a path. I'm opening that path, and then assuming that it is a valid path, then I'm going to try to do some things with that file handler. And then finally, no matter what happens, I want it to close, even if an error is raised. So let's look at this in my code here. So I have a pathlib, right? And then I created a function called stuff that errors. And I accept just really any object, but I'm assuming that it's going to be a file handler. I'm going to print out that file handler, and then I'm going to raise an error. And this is how you can actually raise your own errors and cause the system kind of to shut down, essentially, or to say, hey, something really bad is wrong. And I'm just using a generic not implemented error here for that. I've created my path here. I'm going to open that path. Then I'm going to try to do something that errors here. Okay. And then finally, what I'm going to do is I'm going to have this print and then this close. I'm going to show to you that this actually works. And in fact, I'm actually going to print out this guy right here to show you that this doesn't get executed, but this will get executed here. So I'm going to set a breakpoint right here, and I'm going to debug my file. And now we break right here. I'm going to step over, see that the path is there. I'm going to step over this, and we get a file not found error. And so let's see here. What did we do wrong? Let's try copying it directly to make sure that we didn't get something wrong. We're going to stop this. We're going to rerun this again. I go over this guy. There we go. Must have mistyped it. So now I've got my file handler and it's open. I'm going to go into this stuff that errors, right? So I get a print statement and I can see that this got printed out, right? Now this is going to raise an error. But before the error gets raised, we execute what's inside of here. So we print this and we now make sure that that's closed. Now this guy has been raised. This guy gets raised in there. But you can see that the file handler has indeed been closed. So this finally block gets executed no matter what, even if this has raised an error. And just to prove to you that it's not just only in the case of an error, I'm going to comment this out. We still have something going on in here. We're going to rerun this guy again. I'm going to step over these statements, step into this one. We see that my file handler gets printed out. And now we move to the finally clause. This guy gets printed, and then we also get the end, and now we're done with our execution. So that's what you need to do when you use the close, the file handler .close method in there. It's kind of a lot to deal with, but that's how you make sure that that actually happens. Furthermore, well, we can. This is just checking. This is very similar to what we did in the notebook, or not the notebooks, in Visual Studio, but now that one's a little bit more interactive. So now let's talk about the with statement and how to do that. Basically, what the with statement does is it takes care of that try finally block for you. You don't have to worry about that. So instead of doing this try, do this, and do that, it's all one statement. So we have a with, then our operation, which is open path, and then as fh. Now the as fh means you're assigning this variable name to the output of this open operation right here. And then we print that out. So you can see that this gets done. And now, because our Jupyter Notebook maintains its state, we can check to make sure that that file handler was actually indeed closed in there. So let's go back to this guy and kind of prove to you in this situation, this type of same thing. So what I'm going to do is with open path as fh, then I'm going to do this and print fh dot closed in there to show to you whether or not it got printed. I'm going to run this guy, and you can see this still happens. Yep. So this still happens right here. So we're printing this guy, but that's not actually what we wanted to do. We want stuff that errors with our file handler. All right, let's rerun this guy again. There we go. So true and the end. We got that right here. So let's break that. Let's now do this right here. So now this actually actually going to stay. This actually won't get executed when we run this. So we won't get anything. We'll get a non-implemented error. But let's look into that and inspect that when we debug this and see what happens when we get this. So we're going to run through. We're going to execute this. We're going to run into this. We print out the file handler, and then we get a not implemented error. But let's look at our file handler. Look, it got closed for us. So it actually did get handled for us without us having to do that finally block that was in there. So that's why I say just use the with statement. Use the with statement to get that to work for you, because it's going to be so much better. So when we use the with statement, anything that is one indentation level there is what's going to be executed. As soon as you break that indentation level and you go back out, then that's when that file gets closed automatically for you. So let's talk finally about the different parameters that Open takes. So Open actually takes a multitude of parameters. The first parameter that it passes in is the file path, and that could be a pathlib object, or it can be actually a string that passes in the path to it. Both absolute and relative paths work. The second positional argument is the permissions. So when we do the open function, it by default does a read permissions. But then we also have an RB, which is read bytes, or read it as bytes, a W, which is write, and then a WB, which is write bytes. And then there's actually another keyword argument that you can use called encoding, and that's where you can change the encoding of it. I'm not going to go into too much details. Most files that you're going to be working with are going to be UTF-8 or some sort of variant of that, and it should just work for you. But there might be some cases where you're using ASCII, but if you're using ASCII with a UTF-8, it'll still work. The big thing is if you're using some other type of encoding in there, then you're going to want to use that keyword function that's encoded in there. Note that by default, W is not actually the default parameter here. It is actually read. So R. By default, R is the default permissions for this. So here's how you open a file path using the write permissions. So I'm just going to create a path, or create a path called resources/chronos.txt. I'm going to open that path with the W, or the writing permissions that are in there, and you then print out that file handler. You'll notice that the path is now relative. It's not that absolute path, and that the mode that this is in is W, so it's writing. Now, this is exactly the same thing as if we had done the touch operation of the pathlib. So this is the exact same thing as doing that path.touch in there. This is the same thing as if you had done that, because we're not printing or we're not putting anything into that file just yet. It just creates an empty file that's there. Then next up, we open up that file just to prove to you that it actually does it. And we do it using the bytes or the byte strings, basically, that's in there. And then print that out. And you can see that that is actually a buffered reader. That means that it's actually reading it using a byte array that's in there. So I believe that's it for this lesson. Next up, in our next video, I'm going to have some assignments on how to open and close files for you.